Hey everybody, Trey here. Welcome back to another video. Wanted to do a quick little breakdown of this pretty impressive tornado outbreak we've seen associated with Hurricane Milton today. Started several hours ago with a few discrete supercells just northwest of the Fort Lauderdale, Florida area, and has since really blossomed into a full-fledged tornado outbreak. Here's our current radar, and you can see all of the red boxes there, just multiple supercells moving on shore in the outer bands of Hurricane Milton. Here is the eye of Hurricane Milton, or the what's left of the eye of Hurricane Milton. We'll talk about that in just a sec. That is barreling toward the Tampa, Sarasota area, but these outer bands and discrete supercells well out ahead of the outer bands have been pretty prolific cyclic tornado producers today, including a few tornado emergencies or PDS tornado warnings. You can see the flashing box there. We've seen several of those today, several intense debris signatures with these. And we've seen some pretty impressive images coming out of Florida today. Here's one from a traffic cam of one of the first tornadoes of the day, just northwest of the Fort Lauderdale area. And we've seen some just really impressive images here. This is one on State Route 80 near Clewiston, a very large tornado there, something you would not expect to see in South Central Florida in October, something you'd see in the plains in May, much more likely to see in the plains in May than you would in October in Florida, but really impressive looking image there of a tornado near Clewiston, very large tornado there. Here is one near Indiantown, Florida, and just impressive supercell structure with a big tornado underneath. And those were from some discrete supercells earlier on out ahead of the outer bands, and then the outer bands started, the main outer bands started to move ashore and produce multiple significant tornadoes as well. This was one that hit Fort Myers. Very intense tornado, perhaps even a violent tornado there. You can see all the debris being lofted. Very impressive footage of that tornado that went through Fort Myers earlier. So all in all, a very impressive outbreak that is ongoing and will continue through the rest of the day. Wanted to just do a quick breakdown right now off the cuff as I had all the information up here. Again, there will be more tornadoes as we go into the evening hours today as Milton approaches landfall. But we've already seen a bulk of these storms produce tornadoes today, so I wanted to just do a quick breakdown here while I had the time this afternoon and had the data up in front of me. So let's go right into what is happening just on a broad view. Here's the satellite imagery right now. Here is Hurricane Milton barreling toward the west coast of Florida. Here's Tampa Bay right there, taking a fairly northeast to north-northeast jaunt here today. And it's trucking. Earlier predictions were for landfall sometime early Thursday morning. That does not appear to be the case right now. It looks like we're going to see landfall sometime this evening in the next several hours, somewhere in the Tampa Bay, Sarasota vicinity. But you can see that Milton doesn't quite look how it looked the last couple of days. If you recall, we saw, I'll bring up some images here. If you recall, the last couple of days, we've seen just explosive intensification from Hurricane Milton. Just an absolute textbook satellite presentation there. Beautiful looking eye, really mean looking convection around the eye there. This was yesterday. We saw that a couple days ago as well, as it really had its first bout of extremely rapid intensification to sub 900 millibar central pressure. But as you can see now, it doesn't quite look like that. The western and southwestern side of the circulation pretty exposed here. Not much convection at all on that side of the circulation. All of the rain and thunderstorms really shunted to the northern and eastern sides of the circulation. That is due to some pretty significant deep layer wind shear that we have seen take place, or we've seen Milton move into over the last several hours starting this morning. And that has allowed for a downtrend in the overall structure of Milton. Still going to be a very powerful hurricane as it makes landfall this evening on the west coast of Florida. And the wind field has now broadened out. So instead of a very tight circulation like we saw the last couple of days, the wind field is now very expansive, extending all the way up into perhaps northern Florida, almost up into the Florida Panhandle. And so we're going to see more folks dealing with strong winds, and that just means there's going to be more intense storm surge. A lot more wind to push a lot more water into the very surge-prone areas of the west coast of Florida. So storm surge is going to be a significant issue with Milton as it moves ashore. 10 to 15 feet forecasted from basically Tampa Bay southward in here, and locally higher. We could see some spots of 20 feet or so of storm surge. Just all in all, hopefully folks that live in these areas have gotten out, because storm surge is going to be a significant catastrophic issue as we go into the landfall tonight. But that is just what's going on right now with Milton overall. Let's talk about this tornado threat. Again, a very significant outer band and discrete supercells out ahead of the outer band tornado outbreak that we've seen basically all morning into afternoon thus far. And again, that will continue into the evening hours today as Milton continues its trek northeast. So let's go ahead and take a look. Really, it's a simple answer, and that is that we have had quite a bit more instability than what is typical out ahead of these tropical cyclones. So first, I want to show you what has been going on at the surface here since this morning. So we've got a loop here of surface data. Unfortunately, we don't have a real high-resolution network of stations here across Florida, but we can still depict some interesting, an interesting feature here in this surface data, and that is a little bit of a differential heating boundary or baroclinic zone that has developed across central Florida. And this is baroclinic zones out ahead of tropical cyclones are fairly helpful in aiding in tornado potential out ahead of tropical cyclones. This was a paper by Edwards and Petrika. I'll put a link to this in the description box below, where they go through different types of baroclinic zones out ahead of tropical cyclones, and they found that they definitely do tend to help with tornado production out ahead of tropical cyclones, depending on which type of boundary you have. They split it up into a few different types here. That's for a different video, but basically the bottom line is that we have a little bit of a differential heating boundary or baroclinic zone that has developed across central Florida this morning into afternoon. This is at 12Z this morning, and you can see already a little bit of perhaps a differential heating boundary somewhere in this vicinity here. It's somewhat subtle. You can see a little bit of a wind shift though here across this portion of the Florida Peninsula. This was at 12Z again, so 8 a.m. Eastern Daylight Time. Winds out of the east, northeast to the north of this boundary, more out of the due east or slightly south of due east to the south of the boundary. So a little bit of a wind shift there, a little bit of a temperature gradient as well. Temperatures in the mid to upper 70s to the north, temperatures in the 80s to the south. So a little bit of a baroclinic zone that is lifted north ever so slightly as we have gone into the late morning and early afternoon hours today. This is at 15 or 16Z, so basically noon Eastern Daylight Time, and you can still see that boundary in place across this area. A little bit more defined temperature gradient at this point, right about lunchtime there. Temperatures still in the mid 70s to mid to upper 70s, maybe barely in the low 80s out here to the north of the boundary. Temperatures soaring into the mid to upper 80s to the south here. You can see down here temperatures in the 84 to 87 range there across the southeast coast of Florida. We'll come back to that in just a second, but overall here, this baroclinic zone has helped kind of focus and kind of overlap the strong wind shear and strong instability to the south of it, and right over to the south, along and to the south of that boundary is where we've seen a bulk of the tornadic activity so far. If we just look at our radar data here, you can see if we were to just kind of draw in that boundary here somewhere, if we were to guess, somewhere right in here, most of those tornado warnings have been along and to the south of that baroclinic zone. So that has been kind of a focus and kind of a northward limit for the most favorable environment in this case. So baroclinic zone, we've had a little bit of a boundary in play that always seems to help. It's somewhat akin to these Great Plains tornado outbreaks. We know boundaries can do some pretty interesting things tornado-wise. And to the south of this boundary, there has been the instability really has been the kicker with this setup. So here is our SPC mesoanalysis page, our latest instability. You can actually kind of see where that baroclinic zone is set up, that instability gradient somewhere in here to the northeast of the cyclone center, which is somewhere right in there. So there's kind of your baroclinic zone. To the south of that, we have seen pretty robust instability develop, 1,000 to even 2,000 plus joules per kilogram developing in this area to the south. That is somewhat unusual for tropical cyclones. Usually we see a lot of cloud cover, very saturated air mass out here, out ahead of the tropical cyclone. That has not really been the case today, and I'll show you a couple reasons here why that may be the case. So here is the morning sounding at Miami So basically down here, southern tip of Florida, a little bit removed from where we've seen most of this tornadic activity, but still a decent proxy environment for what we've seen make its way north into the south central and central Florida Peninsula. This is what we've seen today. This was this morning, again, 12 8 a.m. Eastern Daylight Time. Usually you see with tropical cyclones the red line, which is our temperature profile, and the green line, which is our dew point or moisture profile, basically what we call saturated. They're basically on top of each other. And if we look at Tampa Bay sounding from this morning, you get an idea of what a very saturated environment looks like. So that was a little bit closer to the cyclone center this morning. A little bit farther to the east or southeast away from that saturation, we've seen a little bit, some pockets of drier air aloft make their way in. Now, it's not a bunch of dry air, but we've seen these little pockets here where we've seen some slightly drier air aloft. That is going to help kind of desaturate the environment, if you will, and increase lapse rates aloft just a little bit. Lapse rates, that change in temperature as you go up in the atmosphere. Usually with tropical systems, when you have a very saturated environment, those are basically sub 6 degrees Celsius per kilometer, which it looks like it was the case here. But we'll take a look at some RAP proximity soundings in a second. When you have a little bit of drier air in the environment, that tends to steepen the lapse rates a little bit, increase instability, so you have a little bit more robust updrafts. And if we look at, so that was the case here, southern Florida this morning. Wind shear profile started off fairly tame, if you will, still plenty adequate for tornadic supercells. Plenty of curvature there in the low levels of the hodograph. Nice veering and strengthening of the winds with height. As the cyclone has moves closer to Florida, we've seen those wind fields really increase. This was the 18Z sounding at Tampa Bay. Very saturated environment here, but you look at this hodograph, just an absolutely incredible hodograph. 1,000 meters squared per second squared, 0 to 3 kilometer SRH, pushing 900 meters squared per second squared effective storm relative velocity. Extremely strong low-level wind shear here. So wind shear, not usually an issue with these hurricanes as you get the wind fields to strengthen out ahead of the cyclone center, but very, very strongly curved hodographs there, especially in the low levels of the atmosphere, which was an increase from this morning. Initially, we saw a couple supercells that kind of started off very, very small. And most of these supercells have been somewhat small, but this was earlier this morning. You can see these supercells out here, kind of the initial thing that kicked off this tornado outbreak were these very small supercells. You can see they're very, very tiny. That was because we had very small storm relative inflow. So this vector right here, very small, maybe just over 20 knots or so, which is on the small side. That tends to mean smaller supercells, but we still had lots of streamwise vorticity. So lots of streamwise vorticity here. That's when you have your storm relative wind vector and your horizontal vorticity vector, which are pretty much parallel. That has been the case throughout the entire day. And that combination of weaker storm relative inflow and strong streamwise vorticity tends to more efficiently tilt and stretch vorticity into the vertical to aid in tornadogenesis in supercells. So that's why these little mini supercells kind of started off the day as very prolific tornado producers themselves. And then you had these additional supercells in the outer bands move on shore and produce tornadoes as well. But that was the environment as it's kind of progressed throughout the day. But really the instability is the kicker here. Shear, again, is not usually a big issue with these tropical systems because the wind fields are so enhanced out ahead of the center of the cyclone. It's been the instability. So this was, again, this morning, we had already quite a bit of instability in place, 1,500 joules per kilogram mixed layer CAPE. And that is pretty much on the higher side for tropical cyclones. And that has been due to, again, perhaps a little bit of that drier air working its way in. But it has also been due to quite a bit of clearing in the environment. This is the visible satellite going back to this morning, 13Z, so 9 a.m. Eastern Daylight Time. And you can see here, over Florida, this is Milton down here, over Florida, quite a bit of clearing persisted throughout the morning. This is, again, somewhat unusual for these tropical cyclone cases, but plenty of clearing out here. And you can see those initial supercells kind of going off right there near Lake Okeechobee. But this amount of clearing definitely led to filtered heating, of course, solar heating, lots of it. Again, you don't often see this degree of surface heating in a tropical cyclone case, but that is what we got today. That helped get those temperatures up into the low to mid 80s and really boost that instability in the deep layer and in the low levels here. So I've pulled a couple of RAP proximity soundings from 16 and 17Z today. and these are going to be in proximity to those tornadic supercells. So this is at Fort Myers at 16Z, just before that significant tornado went through town. And you can see what has happened. Those temperatures, probably, again, this is a fairly saturated profile, perhaps not quite accurate based on what we saw with the Miami sounding this morning. Perhaps a little bit more drier air in here. We do see some convection being registered on the model that does have some impact on the overall thermodynamic profile. We can still get a good sense of what the thermodynamic profile looks like here from this particular proximity sounding. And you can see what has happened. Perhaps some of that drier air, which not really registering here, and that strong surface heating allowed instability to increase. This is much too low, as we can see on our SPC mesoanalysis page. We're again looking at 1,000 to 2,000 plus joules per kilogram of CAPE that has infiltrated this area of the southern half of the Florida Peninsula. So this instability overall on the deep layer, certainly an underestimate. But take a look at where that instability is in the overall profile. You can see very fat CAPE down here, really below about 6 kilometers or so. So all of that instability that's in the environment is really packed down into the lowest few kilometers of the atmosphere. Our 0 to 3 kilometer CAPE just below 100. I'm sure it was higher than that if we look at our SPC mesoanalysis page and look at our 0 to 3 kilometer CAPE. You can see that we are well in excess of that, 100 to 200 plus joules per kilogram 0 to 3 kilometer CAPE, really across the entire region of that southern half of the Florida Panhandle. So very, very strong low-level instability. Those lapse rates in the low levels has steepened because of that stronger surface heating than normal, and that has allowed us to have adequate instability, more than adequate instability, really abnormally high instability for tropical cyclone tornado events, with much of that located in the lowest levels of the atmosphere. We know why low-level instability is good. If you followed the channel for any length of time, you know why strong low-level instability is a good thing for tornado genesis. It can tilt and stretch any little spin into the vertical very, very efficiently to aid in tornado genesis in supercells. When you couple that with very strong low-level shear and streamwise vorticity, that is going to lead to very prolific, very efficient tornado-producing supercells. Here is more so out to the east, a little bit toward the south central Florida Peninsula, just to the northwest of Lake Okeechobee at 17Z, so really right in the heart of this tornado outbreak. Here's Lake Okeechobee. I took it kind of from right in here, just southeast of Sebring. And again, this is at 17Z, so a couple hours ago, right in the heart of this outbreak. And you can see here, very much the same with even stronger low-level instability out this way. Very, very adequate instability, 1,000 joules per kilogram as registered on the RAP. Again, that is an underestimate most likely. We're probably pushing about 2,000 joules per kilogram out in this portion of the Florida Peninsula. But a lot of that relegated to the lowest few kilometers of the atmosphere. Very, very fat CAPE in the lowest few kilometers of the atmosphere. 0 to 3 kilometer CAPE in excess of 100 joules per kilogram. Couple that, again, with strong low-level shear, and that is going to get you a pretty prolific tornado-producing environment. We saw this kind of environment on April 26th, 2024, this past year, and that was that big outbreak in eastern Nebraska, western Iowa, that produced a lot of very photogenic, intense tornadoes. And that's exactly what we're seeing here. And so you can see how this kind of parameter space can produce pretty intense tornadoes very efficiently. Strong low-level instability, strong low-level shear, strong vorticity near that baroclinic zone, and out ahead of the tropical cyclone. That is a recipe for very efficient cyclic tornado producers that can produce intense tornadoes, especially when you have this much shear that is in place out ahead of tropical cyclones here. 600 plus effective storm relative felicity with this much low-level shear. That is going to lead to very efficient, significant tornado-producing supercells. So that really has been the big case, the big kicker here with this particular event. Perhaps some of that dry air starting to work its way in. You can see once again the satellite, some of that dry air maybe kind of working its way in, but we've had a lot of surface heating here on the southern portion of the Florida Peninsula out ahead of Milton, and that has allowed low-level instability, low-level lapse rates to really increase through the morning and early afternoon, and that has been able to very efficiently stretch vorticity into the vertical. And with that plus low-level shear, this amount of low-level shear in place and these photographs in place, that has been a pretty clear indication of a significant tornado-producing event. And just to show you here, We've seen these photographs really enlarge through the day. So going back a few hours, they were very favorable for tornadic supercells, but as we have gone through with time, you can see those photographs really enlarging, and they will probably continue to enlarge through the afternoon as the strong winds, the strong low-level winds out ahead of Milton make their way into the Florida Peninsula. So we're going to see this tornado threat persist for quite some time into the evening, really until Milton makes its way across the Florida Peninsula. So these outer bands, very, very robust, and these discrete supercells out ahead of these outer bands, very, very robust supercells within them, even as far down to, again, the kind of Fort Lauderdale, just west of Fort Lauderdale. We will see these continue to produce multiple tornadoes as they move off to the north, as Milton makes its way off toward landfall sometime this evening in the Tampa-Sarasota area. So all in all, a very simple explanation for why we've seen a prolific tornado outbreak so far with this setup. As that is because strong low-level instability has coupled much stronger than normal low-level instability with the tropical cyclone case has coupled with very strong low-level shear and vorticity out ahead of Milton, and that has been tilted into the vertical to aid in tornadogenesis in these supercells. We've also seen a very discrete supercell mode. The forcing out here very typically is not quite as strong out here. Out ahead of these hurricanes and these outer bands, the forcing is a little bit on the weaker side, so you're not going to see a big squall line, for example, out ahead of these hurricanes. They're going to be just discrete supercells in a somewhat more subtly forced regime, and that is exactly what we've seen today: multiple discrete to semi-discrete supercells persisting, and that, of course, as we know, is a favorable storm mode for significant tornadoes, especially in this kind of environment. So again, folks in Florida, bracing for impact for Hurricane Milton today. West coast of Florida, all the way up and toward kind of the Big Bend region even, going to see impacts here of some strong winds. Again, that wind field broadening out, so lots more folks feeling the impacts of wind today, but that wind thankfully is decreasing given all of this shear and dry air working its way in. But storm surge is going to be a very critical issue going into this afternoon and evening. Already is an issue, no doubt, in these areas, especially like Tampa Bay, down the western Florida coast, as all that water is getting pushed inland by Milton, and storm surge going to be a very critical issue. Catastrophic storm surge, 10 to 15 plus feet here, especially to the south of Tampa Bay. So folks hopefully have gotten out of there. If not, definitely need to get to higher ground as soon as possible. But this tornado threat once again will continue going into the afternoon. Again, a ton of tornado warnings today, probably approaching 100 tornado warnings or so now by this point, with several PDS warnings that have been issued. This is a pretty prolific tornado outbreak, and we've seen why that has been the case in the environment. So that is going to do it for this video. Folks out there, definitely stay safe. If you have not been able to evacuate, definitely need to be in a sturdy shelter today. Storm chasers out there definitely need to stay safe as well, as Milton is still a very powerful hurricane and will have, no doubt, life-threatening catastrophic impacts as it makes landfall sometime in the next several hours. So that's going to do it for this video. Thanks for watching, and we will see you in the next video.